In this video, we will discuss forecasting in a supply chain. Depending on the goal, the forecast information that we focus on can be very different. For instance, the long-term forecast is mainly needed for making strategic business planning decisions. The mid-term forecast is mainly used for sales and operation planning, in which we focus on the operation capacity planning. Finally, for the master production scheduling and control, in which we focus on the quantity to produce or order, we rely more on the short-term forecast. Strategic business planning includes tasks such as capital expansions, new product development, or even merger opportunities. The planning horizon for those tasks are usually long and often measured in years. Also, such decisions affect the company's operation in a very long run. When doing the forecast, we need to consider what might happen in 1 year, 5 years, or even 10 years. Of course, it is very difficult to predict what happens in such a long period. Besides, there is often no concrete data available. So those forecasts usually will be very general and rely heavily on the public records. For the sales and operation planning, the decision is mainly about how much to produce for each product line and how much workforce to maintain. So the forecast length can range from months to quarterly or up to 1 year. The data that we rely on will be mainly coming from historical and current demand and information provided by the downstream customers. For the master production scheduling and control, the decision is mainly about how many parts to produce or assemble each day or each week. As a result, it relies heavily on historical information unless there are significant changes. Also, because we can adjust the plan within a very short period of time, we only need to predict up to days or a few weeks. Those type of forecasts is very detailed and require better accuracies. However, they have to be done frequently. Now, let's discuss one of the most used methodologies in the forecast, regression analysis. Regressions can help us describe a functional relationship between two or more correlated variables. For instance, linear regression is probably something that you are familiar with, and it can help us predict what might happen based on what we know using a straight line described on the formulations on this slide. The linear functions is determined based on the least square method, in which we try to minimize the square of the vertical distance between the data point and the regression line. Let's use an example to see how we can obtain the regression line from Excel. So suppose that we want to predict the future demand using Excel, and this is what we can do. The first thing you want to check is to click the tool, and there's an Excel add-in. You want to make sure Analysis Tool Pack is selected. Once you do that, you will see the data analysis on the data tag. So when you click the data analysis, you can select various different tools that will be available to you. And here what we want to run is regressions. So you just click OK. Then the next thing you want to do is to give the program the Y range and the X range. In this particular type of analysis, the Y will be the thing you want to predict. So in this case, Y will be our demand. And for X will be our time stamp. So the time will be from 1 to 12. And you can put the output in a separate table, but we can also put everything on the same page to make everything easier. So let me change the output option to output range, and we can put the range to say A19. So everything will be starting from A19. Okay. And when you click OK, the result will come out. That's how you run regression in Excel. Once we obtain a summary output as shown in the demo, we can use the coefficients to identify the regression functions. In this particular example, y equal to 441.67 plus 359.62x. Then, suppose that we want to predict the demand for quarter 14 using the regression functions. We just need to replace x by 14. Then, the predicted demand will be equal to 5,476.35. So, the next questions we want to ask ourselves is, how much confidence do we have about these predictions? To address these questions, we can check the regression statistics from the summary output, particularly R-squared and standard error. R-squared is the statistical measure of how close the data are to the fitted regression line. It is also known as the coefficient of determinations. The value of R-squared will be somewhere between 0 and 1. In general, the higher the value, the better the result. The standard error of the estimate is a measure of the accuracy of the predictions made with the regression line. In general, we want the value as small as possible. Note that linear regressions is not the only regression available to us. There are other types of regressions too. For example, nonlinear regressions has a regression function that is not linear, and it can be a curve. We also have a largest or multinomial regressions, which can predict the probability of some events for given independent factors. For instance, the probability that the customer will make the purchase for a given price, or the probability that a customer will wait in line when there are more than, say, 10 people who are currently waiting. For example, this slide shows the predicted of the height based on gender, race, and age. And this slide predicts whether a patient may or may not have a particular medical conditions based on whether they have diabetes, hypertension, and their BMI. Now, let's switch the gear and talk about time series analysis. Often, the data may contain one or more components of demand, such as trend, seasonalities, and random factors. One of the important tasks in time series analysis is to catch those factors. There are two common ways to decompose the time series. In the additive form, we assume the forecast result equals to the average of the demand plus the seasonal constant. In the second form, we assume the forecast result equals to the average demand times the seasonal factors. So what is seasonal factors? Seasonal factors is the amount of corrections that will be needed in a time series to adjust for season of the years. For example, if the average demand for the years is 250, suppose that the seasonal factors from Q1 to Q4 are 0.8, 1.2, 1.0, and 0.5. Then the predicted demand for Q1 to Q4 will be 200, 300, 250, and 125. How do we calculate the seasonal factors? We can find the seasonal factors by first finding out the average quarter demand for each year. Then the seasonal factors can be calculated by using the actual demand divided by the average demand. We can even combine the seasonal factors and regressions together. To do that, first we need to find the seasonal factors. Then we need to deseasonalize the demand using the seasonal factors we found in the first step. Third, we need to use a regression analysis to find a regression line based on the deseasonalized demand. Finally, we use the seasonal factors to put the seasonality back to the predictions. Let's see an example to see how it can be done. Let's assume we have a demand for 3 years. The first step is to find the overall average demand. Next, we want to calculate the average demand for Q1, Q2, Q3, Q4 separately. For example, the average demand for Q1 will be the average of 2013 Q1, 2014 Q1, and 2015 Q1. Then we use the average quarter demand divided by the overall average demand to find the seasonal factors. Finally, we use the demand divided by the seasonal factor to find the deseasonalized demand. In the next step, we want to find the regression line by using Excel. So we run the regressions on the deseasonalized demand. In this case, we obtain the regression line y equal to 555 plus 342.18x. Then, using the regression functions, we can find the predicted deseasonalized demand. Then, using the seasonal factors from step 1, we will be able to find the predicted demand with seasonalities. Finally, let's work on an example together. Here we know the regression result already, and what we want to do is to use the seasonal factors and the regression function to find out what will be the predicted final demand. So the first thing we want to do is to look at the result from the regressions, and particularly we want to focus on the intercept and the x variable 1 coefficient. So we know our regression function will be equal to y equal to 685.03 plus 265.78 times x. Then the next thing we want to do is to find the predicted deseasonalized demand. And we know Q1 will be 5, Q2 will be 6, Q3 will be 7, Q4 will be 8. So here for Q1, the calculations will be equal to 685.03 plus 265.78 times 5. And the result is actually equal to 2013.93. Okay, let me write it down right here. And you can do the same thing for the Q2 or period number 6, or Q3, period number 7, and period number 8. And let me skip the formulation and write down the answer directly. And for 7, it will be 2545.49. Last one will be 2811.27. Okay? Then for the predicted final demand, it will be the predicted deseasonalized demand multiplied by the seasonal factors. So for the first one, it will be 2013.93 multiplied by 0.8. Second one will be 2279.71 multiplied by 1. Third one will be 2545.49 multiplied by 1.5. Last one will be 2811.27 multiplied by 0.5. And the final answer will be 1611. Second one will be 2279.71. The third one will be 3818.24. The last one will be 1405 times 64.